All right, namaskar. Before that picture starts looking like me, once you settle down, then we can quickly get going. Does this work? Okay. Firstly, I want to thank you, Vikram. Very importantly, Tiara. It's for you that I'm here. And it's just been a marvelous gathering here. And more importantly, I really enjoy the theme of this event that attracted me to come here. The theme is so important at a time that all of us who has prospered in this world, thanks to the digital revolution, a lot of people call it transformation, the way we have experienced it, the way we have prospered, the very governing law of that digital revolution has shifted. And it's so important to get a feel of that so that once we start working around it, we are able to take advantage and keep the glory of our country at its maximum. So I'm going to spend about 20 minutes or so touching upon some really important points, some that you are aware of, but some that might come as renewed energy to make sure that you are able to benefit out of it. Now, a lot of people look at this chart and they tell me this is history of the computer industry. I look at this chart and I say this is a timeline of the economic law. There has been an economic law in our industry, extremely silent, very predictable, and always consistent. What it has done for us, it has helped us with planning, with our budgeting, and for our growth. And this economic law has been referred to as Moore's law. It's not a law, it's actually an observation, but it's literally become a law. But if you look at this third part of that picture, which is showing you the Moore's law, you realize that it has become flat. And it has become flat after 60 years because of physics and economics. And just to get a comprehension of this, many of you, I know almost everyone has a smartphone there, right? The smartphone that you have, and you take one step back, and you see the computers that you use, the lovely laptops that you have, sometimes you use desktop, you go one level before that, which was about client-server machines. But many of you probably in this room, with the exception of people who are here on the dais before me, wouldn't remember there was a product called IBM S360. IBM S360 was so special that it introduced the concept of general purpose compute in year 1964. And the reason why it was very popular, because most importantly, it abstracted the application layer from the hardware layer. By removing the application layer, the value of the application really continued, and it prospered because of Moore's law. Every 2 years, you will reduce the cost of that software. That means there was a deflation. 50% reduction, you could do so much more. And that's exactly how the computer industry got established. Like all things come to an end, Moore's law stalled. Fortunately, there was a contrarian vision that got envisaged around 30 years back. And it was really subtle because it didn't try to replace the CPU, which is at the heart of general purpose compute. It was all about augmenting the CPU. How would it do it? By offloading from CPU to the GPU. And by virtue of that, you could now accelerate and you could speed up things enormously well. Not only would you improve the speeds, but you will also make it extremely efficient. And that's why this platform has come into existence exactly at the time when all of you are figuring out three things. Firstly, how do you apply generative AI? Secondly, how do you do industrial digitization? And thirdly, how do you ensure your ESG goals are met? So just keep this into perspective. I will now touch upon the next frontier, which is also getting into an impact. Now, all of you are familiar with this slide. The left side of the slide is exactly where India has made its glory. This is about writing software through experts. They program it in sequence. They understand what the domain experts want. They visualize to best of their capabilities how to do it, and they write it on general purpose compute. Challenge? They can't figure out every single options that are available and what are the scenarios that are available, so they do struggle. For example, if somebody wants to recognize a face in a crowd, how do you do it? If there's a call that is coming, how do you understand the nuance of the call? Is the person happy? Is person upset? Is he getting built up for that? Those scenarios are extremely difficult, and therefore there's been this major shift towards machine learning. Now, everybody will tell you artisanal is always good, and industrial means mass, so you miss out on nuances. But this is not industrial from that perspective. This is about bringing nuance into play. And as machine learnings have come into play, where you take hordes of your experiences, what people call as digital experiences, which is nothing but data. You pour this data onto neural networks, and it understands your patterns, and it can now figure out what exactly could be predicted as a next step. Take an example. Take an example of somebody who is day in and day out giving approvals for your loan application. If it was the prior model, yes, they will do if and then. If your credit score is, let's say, below 650 and your debt to income ratio is less than 40%, why don't you flag it off and I'll look into it? But what if I took all the applications and poured those applications on neural network and said to it that whether it was approved or disapproved, try and make sense of it. There could be a context in which you don't need to flag it off. And that's where deterministic with probabilistic is the way future, very importantly for our nation, who has this industry, and possibly the only industry that I know of in India, which exports more than what it domestically consumes. So how do we keep that growth, that glory in play? Now, to understand that, and that very shift that has taken place both on the economic law as well as on the software build-up, let's try and understand what really is happening in the physics of AI. Now, this is kind of a schematic diagram. Some of you have heard about it. You absolutely heard, because everyday newspapers are shouting that my language model is better than the others. There are about 5 or 6 companies on daily basis they talk about my model is better. Question is, they are better with a generic information which has been scraped over internet and has become a ground truth. What is important for each one of you, whether you are in startup, whether you are an investor, is to really figure out what you want to do with it. Now, a lot of people will tell you it's hugely expensive, that race is already lost, why do you want to even get at it? And you'll immediately say, why don't I partner? But many of you in this room and many of the people that you serve outside this room also have a lot of information which is so unique that differentiates them, and that's why they have the highest economic value. Wouldn't you like to build that up? Wouldn't that be a build choice rather than a partner choice? Wouldn't that keep you more competitive? Wouldn't it keep you more defensible? That's the choice that you need to make. There's nothing wrong with either of them. One allows you to take upfront cost, make it like a project, just like you'll set up a power plant. Set up a plant for intelligence right there, and it can differentiate you. The other could be, okay, I don't have the resources, I'm happy to do 80% of the job, I want to partner. So please take a note that the large language model, all the training that is taking place, it is for you to take a decision. The second one is that even though this great development that is happening on language models, and you're building these enormous engines which are looking really smart, you still, when you bring them to your organization, you need to fuel them up. And I know in every organization, the fuel that you have is of a quality of a race fuel. And if you have that fuel, how do you infuse that fuel into this engine? The years of customer data that you have, analytics data that you have, insights that you have, how do you bring them on board? Now, many of you remember that 90s was about single backbone being created in organization. At that time, whoever looked at MRP, ERP, CRM, supply chain management was only serving one community in every organization. That was marketing. In this era, as you look at this, you're actually doing it for HR people, because you're going to be creating digital species that will reflect you, your value, your company's value, and you'll onboard them. Who does the onboarding? The HR does onboarding. Therefore, you've got to get the HR teams really engaged, how they're going to be bringing these digital species, which are going to make you even more productive. And in that law, or in that scale of law, you have to be continuously investing money, just like you do with your employees. Every day you expense it, you call it OPEX, and they keep getting better and better. Exactly the same thing is what you do. So if the first one was an engine, which is a decision to do CAPEX or OPEX, the second one is absolutely the OPEX cost. The third, of course, is very interesting. Many of you got used to ChatGPT. I used to hear lots of words that ChatGPT is great in giving me answers, but it hallucinates. And all of you forget that when you were growing up, our parents bought us encyclopedias, and it was time-stamped. Every time we had to do a project using those Britannia encyclopedias, it was always outdated. You still had to add a little bit more if you really wanted to score well. This is exactly the same thing, except that now, instead of giving you fast answers, and fast answers that could be wrong, now it gives you right answers through thinking. It can take a very complex problem, and it can break it down into smaller parts and give you answers. It's also given you a throttle to your expenses. Now, if you want to ask a question that, hey, how was my sales in the last quarter, it'll quickly tell you X percentage. But if you were to ask it, hey, my next quarter forecast is this, but tell me what are the 3 underlying problems and how should I overcome it, it can now think, break it into context, and give you the answer. So that's a reasoning part. And you got to throttle how much of expense you want to pour onto it. So 3 scaling laws that every one of you should know about it. It's your decision, and you got to make sure that you take the right decisions on these ones. This most of you understand, but I'll quickly go through it. A lot of people say AI has been on for 60 years. That's true. But something very special happened in 2012. It was called the Big Bang of AI. We solved computer industry's longest standing problem of perception. You could see and hear now. And the smart business people figured out that we have come to a stage where we can augment the work of our software engineers. That became your digital assistants. Because it became your digital assistants, it added productivity, and a lot of projects got underway, AI got renewed, and people started getting hope that AI will solve many, many problems. Very quickly, from hearing and seeing, because of the work the transformers had done, we saw the advent of generative AI. So it was not just an assistant. Now it could be a collaborator. It could bring in you new content. It could understand the context, and it started making your life easily. This is a period of time everybody was excited in 2023 when they saw ChatGPT. Not many remember that ChatGPT was already in its 3rd phase. And what you saw was a matured model that helped you to now start collaborating with that. With the generative AI coming in, the next question was, how much of automation can I bring in? And here was a problem that a lot of people called it agentic, some called it agents, and everybody believed that tomorrow onwards, I will automate my entire processes. Ladies and gentlemen, you've been automating your processes from the time I got into the IT industry. So automation was not purely about connecting things, it's about autonomy. How much autonomy can you build against a goal, as a goal into a plan, and a plan getting executed? And it's like everybody gives you an example saying, oh, tomorrow I'll tell my travel agent that I have to travel. Can it book my tickets? If it can book my tickets, it can also book my hotel. If my hotel is booked, can I also get a car into play? That's an enormous task. I know Adya, Shashank is somewhere in this room. He'll tell you that how quickly he can build it up. But the fact remains is that agentic is upon us. We require these digital species to work with us, and they will help us to get more and more autonomous. The part that is very quickly working, and you can get a semblance of this with Miko, who is also here in this room, is how do we take the world that was built in digital and pour it into the physical world? Because the physical works on gravity, inertia. How do we bring physics into it? How do we augment our workers who can work exactly with the machine in the way it helps them to augment it? How will we bring humanoids? I'm given to understand that if you take an Apple phone which gets assembled in Hosur, you require humanoids because each of those 172 screws are so minute that a normal human eye can't even see that. So if you have to augment those work, you also need to understand physics, and you've got to build it up, but very, very quickly we're reaching that paraphrase. So if that's been the journey, then it becomes very easy for us to figure out how are we going to work. And there's not going to be a day far if there are 200 people sitting here, 1,800 which are connected online, you might find that's not just 2,000 people, there could be 8 or 10,000 people. You got to really think how you're going to work with that balanced 8 to 10,000 people who are going to add value to you, and how is it going to really work on it. That brings me to my destination to build a future. Build a future, how we're going to do it, and it cannot be done in data centers. It cannot be done in data centers because data centers were designed with general purpose compute to store information. You have to now translate your digital experiences into this concept called tokens, which is a building block of intelligence, and those tokens then need to be poured into everything that $100 trillion industry does it. Be it edtech, be it finance, be it healthcare. If a farmer wants to tell you that I'm not really getting the crop yield the way I want it, then you have to find a solution through an AI so that you can help him in his language, in the way we work. If there is a challenge in healthcare, how do we find that right drug and ensure that before the cell really gets impacted, can we really solve that? And that's why everyone requires an AI factory. Just like how you need a factory to translate your raw goods into a finished good, here you are also doing the same thing, where you're taking electricity, putting it on your raw material, which is your digital experience, and translating that into intelligence. And this happens in a continuum. And as you know, in factory, it's not about the cost, it's about the revenue. So it truly brings you in revenue. Each one of you needs to think about it. And then I really go down to my final destination. What does it mean for India? You know, we are a large economy. We will be soon the third largest economy. We got some great things. We got 1 billion people with smartphones, all connected, makes us the largest digital connected population. We got really smart engineers, some say 5, some say 6, but these are the special people who made our country really shine in the IT industry. There's some great numbers there, 500 gigawatts, all about electricity that is required. And then there is this number 1, must be attracting your attention quite a bit. It's got OpenAI written there. We are number 1 in downloading OpenAI's APIs. And that troubles me. It doesn't trouble me because, like OpenAI, I'm an American company, they are great friends of ours. Because of them, we sell a lot, but it troubles me as an Indian. They say that all Indians put together, every single piece of software that is written, the 8th line has been written by an Indian. And yet, despite writing the 8th line of the software, we use somebody else's search engine, we collaborate on somebody else's messaging, we use somebody else's products even to keep ourselves productive. There's not a single product that we have built that everybody uses it. We are almost Anglo-Saxon. The 5,000 years of civilization today has an opportunity to bring in AI factories, make a network of AI factories, bring in your talent, not only the talent of people who can do programming, but remember that programming today can be done in your own language. It could be as bad in English as I speak. It could be the language you speak with a little bit of mix of English and your native language, and computer can program it. Now imagine AI factories that transfer your digital experiences into data and make a difference to the entire country can truly and truly make you the global capital of intelligence. Wouldn't it be lovely to have Mumbai not only being the financial capital, but actually the global capital of intelligence here? Maybe the capital of intelligence for finance. Wouldn't it be wonderful then, instead of looking at France and Milan for clothing or design wear, we call India the global capital? This is, ladies and gentlemen, your opportunity. This is why you need to build future, and we need to do it together. Nobody's going to come to do for us. Thank you very much for your time.